right, water is flowing from a major broken water main at the intersection of two streets. The resulting puddle of water is circular and the radius r of the puddle is given by the equation r equals 5t feet. T represents the time in seconds since the water main broke. Alright, let me paste the questions on here. Okay, let's get it. There you go, here's the questions. When the main broke, a runner was located 6 miles from the intersection. The runner continues towards the intersection at a constant speed of 17 feet per second. When will the runner's feet get wet? Alright, let's see if we can figure this out. So we have the intersection of two streets. Let's draw that. One street and another street. Again, notice coordinate plane, always useful. And the water main is right at the intersection. So the water is here. And then there's this puddle, that circular puddle that's forming, and the radius of it is given by 5t. Okay. Alright, now we have a runner which was located 6 miles from the intersection. The runner continues towards the intersection. Okay, so it doesn't say where. I mean, we could put a runner anywhere, but it's just easier to sort of put it on the x-axis. So this is the runner right here. Okay, and she's running towards the intersection, and this is 6 miles. All right, if I multiply this by 5280 feet for 1 mile, I'm gonna change it to feet because some of the other stuff is in feet. 6 times 5280. This is 31,680 feet away. And they're going at a constant speed of 17 feet per second. So the speed of this runner is 17 feet per second. When will the runner's feet get wet? Okay, so I gotta figure out when the puddle and the runner meet. Okay, so let's see what's happening here. So the runner starts at 31,680 feet, and then for each second the distance is shrinking by 17 feet per second. So you can say that this is like the distance of the runner, like the x-coordinate, because it starts here and then you're subtracting 17 feet every second. So that's the runner. For the puddle, this value is increasing at 5t. 5 times the time, so this is the puddle. So what we're trying to find is when they meet, when these x values are the same. So if I do 31,680 minus 17t equals 5t, then that will tell us when the runner's feet will get wet. So 31,680 equals 22t. T equals 31,680 divided by 22. T equals 440 seconds. All right, let's divide by 60. Okay, divide by 60 to change it to minutes. So T equals 24 minutes. Okay, cool. Now part B says, suppose instead that when the main broke, the runner was 6 miles east and 5,000 feet north of the intersection. The runner runs due west at 17 feet per second. When will the runner's feet get wet? Because now the scenario is that it's still 6 miles east, so they're still here, but it's not like right there on that line. It's 5,000 feet north. Okay, so this is like 5,000 feet north. And they're running due west. So they're running like this. Okay, so this, and the circle is expanding. Expanding. Oops. And as the puddle, and now it's like, when is the runner hitting that circle? When is it gonna get wet? Okay, so for part B, again we have the x value of, so for the runner, the x value is still this 31,680 minus 17t. They're running at the same speed, but the y value is always 5,000 feet. Okay. The radius of this is 5t, but we need to sort of draw it at an angle now. All right. So we need to figure out when they intersect. Okay, so let's look at the x and y values of the circle. Okay, so the circle equation is x squared plus y squared equals r squared. That's an equation of a circle centered at the origin. Now, when they're going to intersect, the y value of the circle is going to be 5,000, because otherwise that's the y value of the runner too. So this is going to be 5,000. The radius is going to be 5t. And the x coordinate is going to be 31,680 minus 17t. Right? So you basically kind of plugging in the x coordinate of the runner into the equation of the circle to see when the circle and the straight line of the runner will intersect. Okay, so let's go through this problem. So we have 31,680 squared minus 17 squared t squared plus 5,000 squared equals 25t squared. We need to combine these. It's going to be a big number. 31680 squared plus 5,000 squared 1028622 equals 25t squared plus 17 squared, 289 t squared. Add these together, we get 314 t squared. Okay, so divide by 314. Okay. So t squared equals 3275867.52, and now take the square root of that. So we get t equals 1809.9 seconds. If I divide by 60, and we get 30 minutes. Okay, it makes sense that this will take longer, because if she's running like directly towards the circle, like on the x-axis on the street, then it kind of hitting the circle at its widest part at the diameter, but if she's up here, then she's hitting the circle at a narrower part, so it takes longer. All right, and that's it for this problem.